Hello, hi, good morning, my dear students. Welcome to the chemistry class. In the last class, we have discussing about the electrolytic cells, galvanic cell. So, in the galvanic cell, is nothing but it is going to convert the chemical energy into the electrical energy. How it is working, how we are conducting experiments on that. The one of the most important experiment in the galvanic cell is the arrangement of the Daniell cell. So galvanic cell, no doubt it is going to convert the chemical energy into the electrical energy. In the same way, the one of the application of that the galvanic cell is Daniell cell. So Daniell cell is also one of the kind of galvanic cell only, where here the galvanic cell itself is called as a Daniell cell. When we are arranged these cells, we are taking the examples of the two cells. Those two cells should be one is zinc, another one should be copper. So compulsorily when we have taken the copper and zinc, then only we are going to call that a galvanic cell as a Daniell cell. You have to remember this one means the galvanic cell, when we are calling that as a Daniell cell means we are calling this because we are using the zinc and copper. Daniell cell. D-A-N-I-L, Daniell cell. Look here, we will start this one. So here there are different variety of question will be arises in a Daniell cell. The very first one is explain the construction of Daniell cell. They will ask you, otherwise explain the Daniell cell means you have to draw the diagram of this Daniell cell. It's not completed. I will go on explaining you one by one, and I will continue this diagram by explaining one by one. So let's start. The Daniell cell itself, Daniell cell is the galvanic cell. Here we have used the two rods. In that rod, one is a zinc rod, another one is copper rod, another one is copper rod. We have to remember here. So zinc always at the left side and copper should be always at the right side. You have to try this way only. If you have do some mistake, copper you have written left means it's wrong. It's not the Daniell cell. Must ensure you have to remember zinc will come left, copper will come at the right side. Here zinc rod is dipped in a solution. That solution itself is a zinc solution. For example, it is a zinc sulfide. Means zinc sulfide in this solution, zinc rod is dipped here. The first condition. Understand? Similarly here, at the right side, the copper rod is dipped in a solution. That solution containing the copper ions. The copper ions, one of the example is copper sulfide. Look here, whenever I am taking the anions as a sulfide in the zinc, that anion should be I have taken in the copper also. Means zinc rod is dipped in a zinc solution, copper rod is dipped in a copper solution. So here zinc is connected to the copper. Zinc rod is connected to the copper externally through a wire. It's not directly connected, it's connected to the externally. This beaker containing zinc solution, this beaker containing the copper solution, these rod are connected externally through some electrical wire which is contained in the plug key, which is containing the variable voltage. You can vary the voltage, and it is connected to the voltage, means how much current it is passing from zinc and copper in between. So this is the external circuit. Look here, zinc is connected to the anode, that's why we are calling that as an anode. The zinc is anode rod, and copper we are going to call that as a cathode. Copper is nothing but cathode. Look here, the zinc here always undergo the oxidation. You have to remember in the Daniell cell what I must say, at anode always it undergo the oxidation. So oxidation, in the last class I said you, oxidation is nothing but the substance which undergo loss of electrons is called as oxidation. The reduction is nothing but the substance which undergo gain of electrons. So at cathode it undergo the reduction. You have to remember here. So at anode it undergo the oxidation, at cathode it undergo the reduction. So here and the electrons are transposed here from anode to the cathode. Anode to the cathode. Why? Because the electron being a negative charge, it will move always at the positive charge. So this cathode is going to carry the positive charge, this anode is going to carry the negative charge. So here the electrons externally moves from zinc rod to the copper rod, zinc rod to the copper rod. How it moves? How means here zinc is dipped in a zinc solution, and this condition zinc undergo oxidation. How means zinc is going to means this rod which is made up of zinc, the zinc rod undergo the dissolution. So dissolution is nothing but what? Here the zinc rod are going to dissolve in this zinc solution. No doubt already the zinc solution is present in the electrolyte, but even though it is present, but zinc which is made up of the rod, the zinc rod is undergo the dissolution. Dissolution is nothing but what? Think that it is some of the electron. I think it's made up of copper. Simply I am giving you example. If it is made up of copper, if I am going to dip this in a copper solution, that solution means water, and it is containing the copper, calcium only. The water I mixed with the calcium, that is calcium solution is there. In that solution I am going to dip this chalk. No doubt it is also containing the calcium. If I dip it, means this calcium which is made up of this chalk is going to dissolve in that calcium solution only. Means being it is a calcium, it's again going to dissolve in a calcium solution only. The same thing here also. What happens? It is being a zinc, it's going to dissolve. Means this zinc rod is going to disappear. But you are not supposed to say the word disappear. It's not actually completely not. It's disappearing. It means that if this rod is made of zinc, that zinc is going to dissolve. It is mixing with the zinc solution. For that reason, the number of zinc ions are going to increase here. The number of zinc ions are going to be increased here. The main condition here is, look here, zinc rod dipped in a zinc solution, copper rod dipped in a copper solution. Zinc is called as, zinc rod is called as anode, being a negative charge. Copper rod is called as a cathode, it's having the positive charge. The zinc rod is connected to the copper rod by the external wire by the help of plug key, variable resistance, and voltmeter. So here, can you see here? This is a circuit. Is it completely have a circuit diagram? So in the physics we know that. So whenever I use the word something here, the battery is present, plug key is present, some bulb is present. Here some bulb is present. But whenever I make to use this bulb to be put off, this circuit should be connected. This circuit should be connected. Means this plug key should be on. Means one dot should be, we are keeping this. So why? Means the circuit will be the complete circuit when it is having the circuits are connected in a round shape. Means the wire should not be disappear. Means it should not be breakage. Every wire should be connected. Then only we are going to call that as a circuit. I can't call this as a circuit. Why? Means these are not connected. If it is connected, means I can call this as a circuit. So same thing here. Can you see here? The zinc rod, it is connected to the copper rod, but it is not have a circuit. Circuit is nothing but zinc. It is connected to the copper. But these two are not connected. Means it is not. We can't say this is a circuit. So we have to connect it. So then only it is going to form as a circuit. So to make this complete circuit, we are going to add a salt bridge. We are going to add a salt bridge. Here salt bridge is nothing but it is containing the partial transformation of barrier ions. It is containing the barrier ion. So it is an inverted U-shaped apparatus. It is just like in this way, but it is containing hollow, some spaces there. Can you see here? Here it is one of the pole, it is dipped in a zinc solution, but this is closed by the cotton plug is placed here, and here also this is completely dipped in a copper, but it is also closed by the cotton. But what this U2 U-shaped tube, that is called as U2, but commonly we are calling that as a salt bridge. Salt bridge. So here salt bridge is a inverted U-shaped, just like a test tube. Inverted U-shaped bridge, that is called as salt bridge. U-shaped nothing but it is in this shape, but it is not here. It is inverted in the reverse of U-shape. So inverted U-shaped apparatus is called as salt bridge. Here this salt bridge is, what should have the same size? Here this salt bridge is filled by the, can you see here? The salt bridge is not empty. It is filled by the sum of the solution. And the solution is called as saturated solution. The solution is called as saturated solution. That saturated solution is containing the KCl, potassium chloride. First, let me finish the construction first. So, explain the construction of Daniel cell is nothing but the Daniel cell is containing the zinc rod dipped in a zinc solution, copper rod is dipped in a copper solution. These two are connected externally through the wire containing plug key, variable voltmeter and voltage. And zinc is acts as an anode, being a negative charge, copper being a positive charge acts as a cathode. Zinc undergo oxidation, copper undergo reduction. Zinc is dipped in a zinc solution, that is zinc sulfate. Copper is dipped in a copper sulfate, and these zinc and copper are made a complete circuit by the help of salt bridge, where the salt bridge is in the shape of inverted U shape. So that salt bridge contains the saturated solution of potassium chloride. This is called as the construction of Daniel cell. This is the construction of Daniel cell. Up to here, I explained you how the construction is made, how the structure is made. So now we are going to explain you working of Daniel cell. Working of Daniel cell. Probably they will not ask you the construction of Daniel cell. I hope it's very rarely I observed in the only. Not in the annual exams. In the model question paper it was there. Explain the construction of Daniel cell. In the annual exam, they right now they didn't ask for anything about the construction, but they asked about the working. Explain the working of Daniel cell. How this Daniel cell works? Look here, the same explanation it will be continuous here. Working means the zinc rod which is present in the zinc solution, it undergo the oxidation. So oxidation is nothing but at anode zinc undergo dissolution. Look here, you have to remember this here. Zinc undergo the dissolution. Dissolution is nothing but the zinc is going to dissolve in the zinc solution. Dissolving is nothing but what? इसका मतलब क्या है? यहाँ dissolve means the rod which is made up of the zinc. That zinc is going to dissolve here. If it is made up of the zinc, the zinc is going to dissolve in the water. Means it's going to be a disappears, not actually disappears. If I use that word means it's wrong actually. Means it's going to mix here. This rod is going to mix in a water, so that we can say that rod which is made up of the zinc, that zinc is going to dissolve in the water. What happens at that time when zinc dissolves in the zinc solution? What happens means the number of zinc ions are going to increase here. The number of zinc ions are going to be increased here. We have to remember here. So for that reason, if the zinc undergo the dissolution, it means zinc undergo oxidation. Oxidation is nothing but what here? The zinc is going to lose the electron. If the zinc is lost in the electron, then we are going to call that as zinc undergo oxidation. For that reason, at anode oxidation takes place in a Daniel cell. You have to remember, and always at anode it undergoes the oxidation. So at zinc is always present at the anode only. Therefore, it undergoes the oxidation. Look here, I said zinc is going to form as a zinc plus 2 ion. Means it is lost the 2 electrons. Where the 2 electrons lost, and lost electrons are going from zinc to the copper external wire. To this external wire, that electron is transferring. The electron is transferring from externally, and it is moving towards the cathode, which is being the positive charge. So zinc undergo oxidation, it undergoes the dissolution, and electrons are transferring from zinc to the copper through external wire. What here? The next point is copper, which is dipped in the copper solution. Here copper undergo the reduction. Copper undergo the reduction. How means here the copper sulfate is contained in the +2, copper +2 and SO4 -2. Here the cations being the copper +2, they are going to deposit on the copper rod. These are going to deposit on the copper rod. Look here, the copper which is being a cathode in this container, the copper undergo the deposition. Deposition is nothing but what? The solution copper which is present in the copper sulfate, the copper is going to deposit on the electrode. The copper is going to deposit on the electrode means here in the solution, copper being a positive charge, if it is deposit means copper being a positive charge, if it is deposit means it will deposit as a copper, not as a copper +2. If it is lost initially, it is in the form of +2, and copper is going to deposit in this electrode, copper rod, and it is in the form of neutral. Then how it will become neutral means here copper is going to receive 2 electrons. After receiving 2 electrons, that copper becomes as a neutral copper, because in the solution the copper is present. This copper, it is in the form of +2 charge, but when it deposits on the copper rod, it will not deposit in the +2 state, it will deposit in the neutral state. So when it becomes neutral means it's going to receive the 2 electrons. Why? Means it is lost initially. Therefore, the lost electrons, it is going to receive the 2 electrons. After receiving the 2 electrons, that copper becomes neutral. Here copper carrying +2 charge. After receiving 2 electrons, it will becomes neutral. That neutral copper is going to deposit on the copper rod. It's going to deposit on the copper rod. Therefore, copper rod will be present on the copper metal. Copper metals are deposited on the copper rod. Look here. At anode, zinc undergo the dissolution, that is called as oxidation, and at cathode, the copper undergo the deposition. Means deposition is nothing but it's going to gain the electron. For that reason, it is called as reduction. So copper undergo the reduction by receiving the electron, whereas zinc undergo the oxidation by loss of the electron. So here zinc is going to lose the electron, therefore it is called as oxidation. Copper here it is going to take the electron, means it is gaining the electron. Due to the gain of electrons by the copper undergo the reduction. Look here, where the 2 electrons are coming to receive the copper means here zinc is dissolving. The loss of 2 electrons are coming externally through this wire, means the number of electrons are going to collect here. That electrons will be collected, means received by the copper, and it is going to be neutral. For that reason, the electrons are going from zinc to the copper externally, means electrons are moving from zinc to the copper, and at zinc undergo oxidation by loss of electrons. At cathode, copper undergo the reduction by gain of electron. This is the working condition here. Whereas, look here, due to the dissolution of zinc number of cations are increases here. The number of cations are increases here. That increased number of cations will be neutralized by the salt bridge. Similarly here, the number of copper ions are going to be deposited on the copper rod. The number of coppers are going to be deposited on the copper rod. It means that the copper are going to be decreased here, as it means that number of anions are going to be increased here, isn't it? Initially copper sulfates are having equal number of cations and anions. When the copper is going to deposit on the copper rod, the number of cations are going to be decreased. Only the anions will be remains in the more number. It means that the number of anions are greater at the cathode and number of anions are more at the anode. To neutralize this increase and decrease of the ions, it will be neutralized by the salt bridge. What is the salt bridge? Salt bridge is nothing but it is inverted U-shaped structure which is containing the saturated potassium chloride. Saturated is nothing but what? If you take 1 glass of water, try to put the potassium chloride in an excess so that it will completely dissolve. It has to be completely dissolved, and the excess of potassium chloride has to be present in the, has to be settled in the bottom. Means ಎಷ್ಟು ಮಿಕ್ಸ್ ಆಗುತ್ತೋ ಅಷ್ಟು ಹಾಕಿ ಮಿಕ್ಸ್ ಆದ್ಮೇಲೆ ಕಡೆನೂ ಕೆಳಗಡೆ ಉಳಿಬೇಕು. ಅದು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಎಷ್ಟು ಕೆಪಾಸಿಟಿ ಇರುತ್ತಲ್ಲ ವಾಟರ್ಗೆ ಪೊಟ್ಯಾಷಿಯಂ ಕ್ಲೋರೈಡ್ ಡಿಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ಳಪ್ಪ, ಅವಾಗ ಆ ಸೊಲ್ಯೂಷನ್ ಆ ವಾಟರ್ ಪ್ಲಸ್ ಪೊಟ್ಯಾಷಿಯಂ ಕ್ಲೋರೈಡ್ ಅವಾಗ ನಾವು ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ ಸ್ಯಾಚುರೇಟೆಡ್ ಪೊಟ್ಯಾಷಿಯಂ ಕ್ಲೋರೈಡ್. ಇಫ್ ವಿ ಆರ್ added the potassium chloride, then we are going to call it as the saturated potassium chloride. If you are added another salt means we are going to call the saturated solution of that salt. So here saturated potassium chloride is nothing but what? The water containing the sufficient complete maximum dissolution of potassium chloride. ಒಂದು ಗ್ಲಾಸ್ ನಾಗ ಎಷ್ಟು ಹಿಡಿಸುತ್ತಲ್ಲ potassium chloride ಅಷ್ಟೆಲ್ಲ ಹಾಕಿ ಕೆಳಗಡೆ ಮತ್ತೆ ಉಳಿಬೇಕದು, ನಾಟ್ ಹೀಟಿಂಗ್. ನಾರ್ಮಲ್ ಟೆಂಪರೇಚರ್ ಒಳಗಡೆ ಡಿಸಾಲ್ವ್ ಮಾಡಿ ಇನ್ನೂ ಎಕ್ಸೆಸ್ ಉಳಿಬೇಕು. ಅವಾಗ ಆ ಸೊಲ್ಯೂಷನ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ we are going to call that as a saturated potassium chloride. Means I hope you have to remember this one. Saturated potassium chloride is nothing but what? The complete dissolution of potassium chloride, maximum complete dissolution of potassium chloride is called as saturated potassium chloride. So salt bridge is containing the saturated potassium chloride which is dipped in a zinc solution and a copper solution. Here as the number of zincs are increasing, to neutralize these cations, the negative ions are moving here. And you see here this is the cotton. Only the negative ions means chlorine are entering here. Means anions are entering here just to neutralize the cations and anions. Similarly here, as the copper is undergo the deposition, means number of anions are more here. Here to neutralize the number of cations and anions, the potassium ion is coming here, not the purely potassium. Potassium ions are coming here just to neutralize the equal number of cations and anions. If one copper is deposited means 2 potassium is coming. Why? Because the charge of the potassium is +1. The charge of the copper is +2. If one copper is deposited means 2 potassiums are entering. Means 2 potassium ions are entering here. For that reason, why means to make the number of anions and cations equal at cathode and at anode. Means one condition, salt bridge is used to make a circuit complete. One is to make a circuit complete. To make the circuit complete, we are using the salt bridge. Another one is to make the neutralization of cations and anions in the anode and cathode. So in the anode and cathode, at anode the zinc is going to increase. Cations are increasing. It is neutralized by the transferring of chlorine ion by salt bridge. At the cathode, the number of coppers are decreasing. It's the number of anions are more. That will be neutralized by the transformation of positive charged potassium ions. So salt bridge acts as a bridge between the two electrodes and it acts as a complete circuit and it is used for the neutralization of cations and anions in the anode and cathode. Here, so I said you the zinc undergo the oxidation here. Zinc rod is going to dissolve in a solution to form a zinc as a zinc +2 to form zinc +2 by loss of 2 electrons. The 2 electrons will be coming here and for that reason here zinc means copper here is going to deposit copper initially into the +2 charge and it's going to receive 2 electrons. After receiving the 2 electrons, the copper is going to neutralize. Copper will becomes copper 0. Zinc undergo the dissolution by oxidation method. Means zinc is going to form as a zinc +2. Charge is increased, electron is lost. Therefore, it is called as oxidation. Zinc forms as a zinc +2 by loss of electron. Copper is undergo the deposition. Means by gain of electron, copper +2 becomes copper 0. Means copper +2. After receiving the 2 electron, it's going to form as a copper neutral. So here, at anode it undergo the oxidation. Write the reaction taking place at anode in the Daniel cell. They will ask you the question. Write the reaction taking place at anode means at anode zinc undergo the oxidation to form zinc as zinc +2 electrons. This is how they are going to ask the question. Write the reaction taking place at cathode in the Daniel cell. At cathode, what is present? Copper is present. So copper undergo the reduction by receiving the 2 electrons to form the neutral, and copper undergo the reduction due to receiving the electron. Write the reaction taking place at cathode means you have to write this reaction. Sometimes they will ask you together. Write the reaction taking place at anode and cathode means you have to write this reaction. This is called as half reaction. Overall we can write it is as a overall reaction. So zinc undergo the oxidation, half oxidation reaction. This is half reduction reaction. Together it is called as overall reaction. Overall reaction means we have to write it in a together, and we will cancel the electrons, and we will write how the zinc becomes zinc plus 2, copper plus 2, how it becomes copper. This is called as the working of the electrode. So initially I would like to give you one more, the most important concepts here. The charge transferring from electron is transferring from zinc to the copper. You have to remember how the electrons will transfer means from zinc to the copper it will transfer. Zinc undergo oxidation, copper undergo reduction. Initially the electrons are transferring from zinc to the copper. Under condition, the potential difference of the Daniell cell is 1.1 volt. The potential difference is 1.1 volt. The initial potential difference in the Daniell cell is 1.1 volt when the current means when the electrons are transferring from zinc to the copper. You have to remember, I hope you know this one. According to the physics, we know if the thing that is a rod means wire, if the electrons are going from A to B, then current will transfer from B to A. I hope you remember this one. If not, means do remember this one. This is most important. Electrons, in which direction electrons are going, in that opposite direction the current will flow. So how the current will flow here? I said you, the electrons are moved from zinc to the copper. It means that current will flow from copper to the zinc, isn't it? Copper to the zinc, and voltage drop is 1.1 voltage. It is the initial voltage. One thing here. So one more thing here. If the applied potential is, can you see here? We can able to vary this voltage. If the applied potential is less than 1.1, so I said you here initially potential difference inbuilt it is 1.1. Inbuilt it is 1.1. If the 1.1 potential applied external potential, I am talking external voltage. If the applied external voltage is, if it is external voltage, if the applied external voltage is less than 1.1 voltage, if the applied external voltage is less than 1.1, think that it is initially 1.1 voltage is having, I said it is a fixed 1.1. If the applied externally we are adding some current by battery or some current, external voltage if it is less than 1.1, then nothing will happen. Means at zinc undergo oxidation, copper undergo reduction, electron move from zinc to the copper, current move from copper to the zinc, isn't it? Everything will be same when the external potential is less than 1.1. One condition. This is first condition. This is most important, very important. You have to remember this one. Condition number 2. When the external voltage, when the external voltage applied is equal to the 1.1 only. 1.1 volt means in the opposite direction they are applying the external voltage. So 1.1 direction the current is moving. If the external voltage in the opposite direction, if they have applied by the same voltage, initially it is 1.1, externally if they apply 1.1 voltage only, then what happens means there is no transformation of electrons will take place. Means zinc should not undergo the dissolution, it will stop. And stop means the movement of electrons from zinc to the copper, it will not move, and it will also stop. If electron is not moving, then current is also not dropped. The movement of current, it will be zero when the external voltage is applied is exactly equal to the 1.1 volt. You have to remember here. So if it is less than 1.1, the current will move and deposition everything move as it is. If the external voltage is exactly equal to the 1.1, then there is no reaction takes place. Zinc do not undergo oxidation, copper is also not undergo any reduction, electron will not move, and current is also not dropped. Everything will be stopped when external voltage is applied is exactly 1.1. The condition number 3 is when the external voltage applied is greater than 1.1. Greater than 1.1. Here the external which one they are applying, they are opposite to the internal transformation of the current. If the current is going here means they are applying the opposite direction. Look here, when the external voltage is applied is greater than 1.1 voltage, then what happens means then the current, initially electrons are going in this direction, zinc to the copper. If applied voltage is greater than 1.1 means everything will be reversed. Everything will be reversed. Then what happens? The electrons will move from copper to the, means from cathode to the anode. If the electrons are moving from cathode to anode, then current will move from zinc to the copper. We have to remember here, when external is greater than 1.1, electron move from copper to zinc, means current will move from anode to the cathode. At that condition, what happens? Zinc not undergo the oxidation, zinc undergo the reduction. The reaction will be reversed. When the external applied voltage is greater than 1.1, zinc undergo the reduction, not oxidation. Similarly, copper undergo the oxidation, not reduction. You have to remember here, when applied external voltage is greater than 1.1, the reduction becomes oxidation and oxidation becomes reduction. Zinc not dissolves, zinc deposits. Here the copper is dissolution and the every reaction is undergo the reversal. Zinc undergo reduction, copper undergo oxidation, and current move from zinc to the copper, and electrons will be moving from cathode to the anode. We have to remember here, what happens? The external voltage is less than 1.1, exactly equal to 1.1. If the external voltage is greater than 1.1, you have to remember this condition. It is most important. Based on this, you will get the questions. For that reason, this is the working condition. Do practice this. Watch this video if you feel fast or confusion. Most important it is, and how they will ask you the question. I will give you those questions as an assignment. Okay, do practice. We will see in the next video about the continuation. Okay, have a nice day. Bye.